previous lecture, we were discussing about the continuous time and continuous valued signal. We have seen the example of continuous time, continuous valued signal. X of t is equal to 0.8 raised to t. So in this case, if we will plot this particular signal, here the amplitude is mapped on y-axis, whereas the time is mapped on x-axis. At t equals to 0, 0.8 raised to 0, it is 1. Amplitude is 1. And later on, as t keeps on increasing, it is decaying in exponential manner, and finally it reaches to the 0 value. So here we could realize that the signal is defined at each and every instance, and it is varying from minus infinity to plus infinity. It can have any value in between 0 and 1. So this is said to be a continuous time, continuous valued signal. Now whenever we are dividing the time axis into regular intervals and the signal is defined at the specific instances, then that signal is said to be a discrete time signal. So for example, over here, if we look at this signal, we are going to divide the time axis into regular intervals in this similar manner, where these instances pick up the certain samples of the signal so as to define the signal at those specific instances. So in this case, the time variable is defined as n in spite of this t, and this n is integer value whereas t is a real value. So n can have the value between minus infinity to plus infinity. So here n will be either 0, plus minus 1, plus minus 2, plus minus 3, etc. And at these instances, whatever amplitude signal is possessing, that is going to be defined. So whenever we are dividing the signal time axis into regular interval, that means we are performing the sampling operation on the signal. So sampling is performed by replacing t by n into t, where capital T is representing the sampling interval. It defines the sampling interval or sampling time, and reciprocal of this defines the sampling frequency. We will be discussing these matters later on in detail. So at this moment, if suppose we are defining the signal x of t, which we have defined above as 0.8 raised to t, we will replace that t by nt. X of nt equals to 0.8 raised to nt. So let sampling time be equals to 1, which is decided by the sampling frequency of the sampler. So in this case, signal is x of n is equal to 0.8 raised to n, and if we will keep on placing the values of n, so at n equals to 0, x of 0 is equal to 0.8, n equals to 1, x of 1 is equal to 0.8 raised to 1, sorry, x of 0 is 1, then x of 1, that is 0.8 raised to 1, is equal to 0.8, 0.8 raised to 0 is 1, x of 2, that is when n equals to 2, it becomes 0.64. For n equals to 2, it is x of 2, which is equal to, so likewise we could compute the values and the signal could be defined. So the signal is defined at the specific instances. So this process is known as a sampling process, and the signal is represented as at n equals to 0, n equals to 1, n equals to 2, n equals to 3, etc. 0.8 raised to 0, the amplitude of the signal is 1. So it is represented by bar plot. 0.8 raised to 1, the amplitude is 0.8. 0.8 raised to 2, the amplitude is 0.64. So this is a discrete time signal. But here the signal can have any amplitude. It is 1, 0.8, 0.64, etc., etc. So this is said to be a discrete time continuous valued signal. So in this way, by performing the sampling operation, we could generate the discrete time signal. Now next we are going to see the sampling process that we will see in the next video lecture. Thank you.